So up next we have StackQuest. Yeah, StackQuest is a fun experience where you start out as it's a game where you start out with no clothes, and your first thing is that you choose your class, and it's a multiplayer RPG. They have more to say. It's more interesting when they say it.
Hello, everybody. My name is Keto. This is Gabe, Anton, and Jonathan. Together, we built StackQuest, an in-browser and real-time multiplayer adventure game. StackQuest leverages Phaser, React, and Redux on the front end, and on the back end, we have Node.js, Express, SQLite, and Socket.io to provide users with a robust and seamless multiplayer experience. So when a user first registers an account with StackQuest, they're sent to a character selection map where they're prompted to select one of two characters, a wizard or cyborg. The two characters have different stats, attacks, and special abilities that impacts a user's in-game experience. The characters also belong to a unique faction, the wizard in the wizard faction and the cyborg in the cyborg faction. This faction system plays an important role in the player versus player gameplay, which Gabe will now explain along with player versus environment.
Thanks, Keto. So depending on where the player is in the map, StackQuest allows for either player versus player or player versus environment interaction. The StackQuest game is comprised of 3 different maps. There's a fantasy map for wizards, a Mars map for cyborgs, and a player versus player battle arena. The purpose of this design is to allow players to safely increase their stats before having to worry about other players attacking them. In the PvE maps, players attack monsters in order to increase their attack, defense, or health. When the player feels confident in their stats, they can send a message to their faction in order to meet up in the PvP arena and battle. In that PvP arena, players can attack only members of the opposite faction. Furthermore, monsters are not spawned in this area in order to really focus on the PvP action. Now I'll pass it on to Anton to talk more about the enemy pathfinding in the PvE maps.
Thanks, Gabe. In order to add life to our game, we decided early on that the StackQuest monsters would need to chase after active players in the PvE maps. In StackQuest, the monsters are supposed to chase after one player at a time and are confined to the map they are spawned in. We did this using a combination of the A-star pathfinding algorithm and game logic that finds the player that is closest to the monster using the player's X and Y coordinates. We decided to use a Node.js implementation of the A-star pathfinding algorithm as it accounts for map collisions and obstacles when determining the monster's path. Furthermore, the A-star algorithm combines Dijkstra's algorithm with best first search in order to find the optimal path for the monster, while speeding up the pathfinding processing time significantly. Because the user is pursued constantly, the game is high intensity and a lot of fun. Now I'm going to hand it off to Jonathan to talk about our socket system and some of the technological challenges we faced.
Thanks, Anton. So one of the biggest challenges that we faced when we were building this game was latency, or the time it takes for data to transfer between the players and the server. At first, we used Firebase, which is a Google-based server, which handles updates immediately. However, we found that even with Firebase, the latency was still a little too high for a multiplayer action game. As a result, we decided to use our own server and implement sockets. This way, we can control the information the players send and the server receives. This way, when a player takes an action, only that action gets transmitted to the server. The server then processes the action and sends it to all of the other players. Since a specific player action contains very little data, the server can process this very quickly and update everyone else just as quickly. This allows our players to interact with the world, the environment, along with all the other players in real time. Having our own server also allows us to handle monster actions on the server side. Instead of creating monsters from the player's point of view, the server decides where and when to create these monsters. It decides the actions of these monsters, and then sends out the information to all of the connected players. So when a monster chases after a player, or when they're just moving around, when they're attacking players, or even when they're dead, or when they die, all of the players receive the same information at the same time. If you want to check out our app, you can go to stackquest.herokuapp.com. Thank you for listening.
David Nimmet, cyborg or wizard? I'm asking the tough questions.
Wizard.
I think wizard.
Yeah.
Okay. I chose cyborg, but
That was a very fast moving and competitive gameplay. Like I felt like I almost don't want to try this out because I'm worried. I'm worried I won't get any of my work done.
Yeah, look very good. I like their server icon too. A lot of nostalgia in that presentation.
Great work.
Nice job, StackQuest.